Good morning, everybody. It is 5:52 here in Los Angeles. Maybe you can't tell, but I woke up not too long ago, like 40 minutes ago, so it's still pretty early. My hair is still disheveled to the greatest degree possible. I still have to go to the gym and do a bunch of other stuff, but we're off to a good morning. Camera is working again. It wasn't working yesterday. All right, let's get down to business. Let's solve some SAT problems. And today we're going to be doing systems of linear equations. Now, systems of linear equations, you're just finding the intersection of two lines. That's all it is. That's the point at which they intersect is the solution of the system. And some of these are not too bad. Some of these can get pretty tough on the SAT. And we're going to, again, be going from Khan Academy and solving. I'm going to see how much time I have. I may have time to solve all five. That's what I'm going to try to do from now on. I'm going to try to solve the whole set. So I'm not rushing and just doing one and so on and so forth. I think this will be a bit more informative. If you guys have any suggestions or comments as far as how to present these problems or how many to do or what's optimal, let me know. All right. Without further ado, let's switch over to the good old share screen, and let's do it like this. All right, here we go. Boom, boom, and let us begin. So we're going to do a little thingy here. I showed you this before. You can kind of do a cool split screen if you hold down the mouse over the green thing. And now we've got a nice split screen. Let's solve. So first of all, we have, oh wait, question 5 of 5. Oh, I must have done these before. Hold on. How do I reset this? Let me see if I can reset this guy somehow. You know what? It's okay. I will start. Let me go like this. Let's just see if I can skip this. View my results. And then let's see, does this work? All right, I'm going to maybe have to do something else. It looks like I already did that one. Let's do another systems of linear equations. Well, I guess we'll do this word problem one. Yeah, let's go for this. Okay, it's going to be a little longer, so I'll do my best. So let's read it very carefully. The owner of a landscaping company is developing a proposal to maintain the grounds of a building. It is estimated that 75 gardening hours, as soon as I see a number, I write it down, 75 gardening hours and 25 foreman hours. So right off the bat, I know that this is going to be gardeners, I assume. Well, let's see. And foreman, this might not be exactly how it is. The total budget for these hours is $1,600. All right. So this will be the hours times, this is going to be the cost of the gardeners and the cost of the foreman. That's my assumption right there, because we're getting something in total cost. Well, let's keep reading to make sure. The total budget is $1,600. The hourly wage for a foreman is 30% more than a gardener, plus an additional $165 per hour. Okay, so we've got our two equations. So these are definitely wages. So if we add these together, the 75 hours times gardener plus 25 times foreman, it's going to equal our total of $1,600. That's one equation. The other relationship they give us is that the hourly wage for a foreman, okay, that's foreman. Hourly wage for foreman is, right, is always equal. Wage for foreman is 30% more than a gardener. So we do 1.3, because if we take a gardener and we want to raise it 30%, we don't just multiply it by 30%, we multiply it by 0.3, we multiply it by 1.3 plus an additional 1.65. That's it. This is our system of equations. And now they said, which of the following system of equations can be, we don't even have to solve, can be used to determine the hourly wages of a gardener and a foreman, so the total wages are $1,600. So let's look here. It's A, actually. But it's out of order, but let's go through the ones and see why the other ones are wrong. This one, they flipped this one's the top equation's right. The bottom one is, I'm sorry. No, A is wrong, because they flipped see how it's 25 times F, 75 times G, and they flipped it. So it's actually, A is incorrect. B looks like it's probably right. We got 75 gardener, 25 F. F equals 1.3 G plus 165. That's right. Make sure we can tell why this is wrong. Yeah, because this is saying the gardener is 1.3 F. This is not what it says. It says the foreman, where is it? The hourly wage for a foreman is 30% more than blah, 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 blah. And this is the same problem. They have the second equation flipped. So it's B. We could solve it, but they don't ask us to. So that's basically it, just a setup question. All right. Hope that made sense for you guys. Let's get rid of this. Devin is a landscaper who needs to prepare different types of grass seed for his customers' yards. Bluegrass seed costs $2 per pound, while drought-resistant seeds cost $3. Hold on. I'm gonna again kind of jump to the conclusion that it's gonna be 2 times what is it? B and 3D, right? 3 depending on the number of these drought resistant. For a particular day, the 2 types of grass totaled $68, right? This is quantity times price, quantity times price. And now we're looking for the total price. As soon as we have that number, this is the relationship. The total price is $68. And together, I'm sorry. This is quantity specifically in pounds, because we're getting $2 per pound, $3 per pound. Important distinction. And the 2 weighed 25 pounds. That means the weight of B plus the weight of D equals 25 pounds. Now, what does it say? How many pounds of bluegrass did Devin prepare? Interesting. We need to solve for B. So how do we solve for B? There's 2 ways. It's kind of up to your preference. You can either solve by elimination or substitution. My instinct actually in this one would first be to go to substitution, but now that I look at it, elimination is going to be easier. And the way we do that is we got to basically match up only one set of the variables so that we can combine the equations and knock one of them out, have a single variable equation, solve it. So let me show you what I mean. I see that we got a 2B here and just a B here. What happens if I multiply this entire equation by -2? Watch what happens. It becomes -2B minus 2D, right? The 2 kind of leapfrogs, boom, boom, and boom, equals -50. I kind of just wipe this out now because we're not using this equation anymore, or maybe later at the end, but kind of going to put it on pause. I don't want to completely delete it, but now we're going to combine these 2. We're literally going to add them together term by term. So what's 2B plus -2B? It's a 0. Go on. What's 3D plus -2D? That's just D. Put a plus here, but whatever. Equals, what's 68 plus -50? That's 18. So guess what? The number of pounds, I somehow solved for the other one, but that's okay. So the number of pounds of drought resistant is actually 18 pounds. They have 18 here, but that's not right. They're asking for B. But now let's go back to the second equation. And I'm choosing, we could actually plug this value 18 into either of this or this, doesn't matter. But I'm choosing this one because it's simpler. It's what I usually do. So 18 is D, we now know that. B plus 18 is this. Subtract 18 from both sides to get our answer. That goes away. B equals 7. 25 minus 18 is 7. That's our answer. So might get a little tricky. That's why instead of using X and Y with these, like sometimes you might forget which one is bluegrass, which one's drought resistant. So I think using B and D for this guy makes everything way, way easier. And you remember, I want bluegrass. I'm looking for the B, and it's in fact 7, not 18. Okay, let's move on to the next one. How are we doing for time? 6:01. Yeah, we're doing all right, I guess. Ricardo has 2 types of assignments for his class. The number of mini assignments, M, he has is again, let's set up the equation right off the bat, setting up the relationship. The mini assignments, M, is 1 fewer than twice the number of long assignments. 1 fewer than twice the number of long assignments. I'd like to do that crazy L. There's our first, that's it. It's just a relationship. That's our first equation. If he has 46 assignments, guess what? M plus L. If he has 46 assignments total, that means M plus L is 46, right? Because he's only got these mini and these long. The combination of them equals 46. Which are the following systems of equations? Again, we don't have to solve. Beautiful. M equals 2L minus 1. Let's see. I see that here. I see that here. I don't see it here. I don't see it here. C and D are gone instantly. Now we just got to figure out what's the distinction between what? Aren't these the same? Oh, no, they're almost the same. Sorry, I got confused. This one is almost the same. This one, I mean, this one is almost right. This one is correct. We didn't have to go farther than A, but it's okay. Right, exactly how we wrote it up here. Sometimes it'll be a little different. We got lucky. It's exactly how we wrote it, so it's definitely A. But now look how close B is. B is almost the same, 2L minus 1. This is M equals L plus 46. It's not M equals L plus 46. It's M plus L equals 46. That's it. Okay. 2 more questions. Oops. One Saturday, a butcher sells a total of B pounds of beef at $6 per pound. She also sells some pork for $7. Okay. B pounds. Again, we're going to just go for total price because that's often what we're finding. $6 times B. And pork is $7 times P. Again, P represents pork. On Sunday, she sells B pounds of beef again, but at the sale price of $4 per pound. So Sunday she sells the same amount again. So we'll do it like this. 4B, right? Is that beef? She also sells some pork for $9, but now she just sells pork for $9, period. And okay, this is getting a little more complicated, right? So the pork, but it doesn't say per pound. So that means, hold on, sells this 7P equals 9. It looks like we have quite a few equations. Given that she made the same amount of revenue of dollars each day, which of the following system of equations can be used to find out how many pounds of beef she sold each day? All right. Oh, and they just want the setup. So this one is going to be first, right? Oh, sell some pork for $7. I see I read that wrong. Isn't that crazy? It's not $7 per pound. So let me restate this. 6B plus just straight up 7. And now I'm looking at this equation. They use D for the total. Yeah, sometimes need that to help you out. This is Saturday. On Sunday, she sells it for four per pound, makes $9, but makes the same money. So this is an interesting one. See the curveball they've thrown here. The second variable is not the price per pound of pork. We don't even need to know that. They don't even give us the number of pounds she sold of pork, so it's kind of impossible, but we've got these figures here just straight up. That's how much money she made. This is the total. The total we don't know, and we also don't know the amount of pounds for B. Now we have our system of equations. Again, we don't have to solve it, but this is what we have. So now, and it looks like they've written it in flipped order, but let's see. It might be this. D equals, nope, it's not A. D equals 6B plus 7. D equals 4B plus 9. That's it. Right? You just see they flip-flop the equation, but that's okay. Equal sign, there's no order. I mean, you can put it on either side. It's just got to be the same thing. Like this could easily have been written as D equals 4B plus 9. Same exact thing. So this is, I said B, right? I think this is the answer. Correct. All right. Excellent. 605. I can do one more and we'll close out the set of word problems, and let's go to next. A piece of glass with an initial temperature of 99 degrees Celsius is cooled at a rate of 3. Okay, so a glass of 99 is cooled at a rate. So if it's initial, it's just starting at 99. It's cooled at a rate of 3.5 Celsius per minute. So that means this is going down by 3.5 per what? Per minute. So if it's 1 minute, it's going down by 3.5 degrees. 2 minutes, 7 degrees. 3 minutes, 10.5. So the amount is going down. It must be multiplied by, let's use M for minute maybe. Something. Let's try that. Equals temperature. All right. Concurrently, and you notice, actually, see, I should even check this. I got lucky. Look, they use M and they use T. So this is better. And this is good that we're doing this. Concurrently means at the same time, a piece of copper with an initial temperature of 0 degrees. And you can already tell I've kind of flipped it around how I'm writing it. That's okay. 0 degrees is heated. So I'm going to represent heated as adding. Right? We're going to add like this per minute. Let's use the same M. Equals T. Write the following system of equations. So write which of the following systems of equations can be used to solve for the temperature T in degrees Celsius and the time M in minutes when the glass and copper reach the same temperature? So this is going up from 0. This is coming down from 99. When are they going to reach the same time? And this is it. These are our two relationships that you can now combine and manipulate to solve. Now, I actually wish they had us solve this, but they don't want us to, and that's what it is. Now let's look and see which of these equations match up. This one is wrong because look, it's 99 plus 3.5. We said it's minus. It's going down. Wish we could eliminate. D equals 99 minus. That looks correct. T equals 2.5. That's correct. They don't have the 0, but we don't need the 0. 0, 0 doesn't do anything. It's actually going to be B. But let's look at C. This one is wrong again. Now they flip-flopped it. We said that the glass is going down at 3.5, not 2.5. So it's totally wrong. Again, they did the same thing here. And now they're dropping it. Well, here they're adding it. Now they're dropping it. This is closer, but still no good. So our final answer is going to be B. There we go. So those are that's systems of linear equations word problems. Let me turn it back here to the camera. Oh, boom. All right, cool. Yesterday I had some camera problems, so now today it's good to see that it's all working. That's it, guys. And we will continue with more Khan Academy practice problems for the SAT tomorrow. And of course, we're going to soon switch it up and do some ACT problems, as I'm going to be taking the ACT in just a couple weeks now to go through the whole process and just see what it's all about. It's been a while since I took it. And we will ramp up sort of together for that and then go into the battle of the ACT together. Hope you guys enjoyed it. If you have any questions, you can always email me at huzaifa@scalarlearning.com. Check out my other videos as well on my channel. I got some fun music videos for you to see on math-related concepts. That's it. Have a great day. Peace.